This next part here is to do with the activity that you're going to do on the CK12 website. It's to do with projectile motion, and to generalize projectile motion is anything that's kind of thrown up in the air and comes back down and kind of flies through the air and makes a parabolic arc. And projectile motion can be generalized with height is equal to 1/2 the acceleration due to gravity times t squared plus the initial velocity upward times t plus the initial height, okay, the starting height. So for example here, and this is given in feet per second because the assignment that you're going to do is to do in feet per second, but we talk about meters per second. Okay, the acceleration due to gravity is 9.8 meters per second squared. Okay, for this they use 32 feet per second squared. Okay, and that's why when we use the feet per second squared, 1/2 acceleration due to gravity is going to give us -16. Sorry, that's going to be negative because it's going down. We're going to get -16 as 1/2 acceleration. Okay, so when we are given the initial height, the initial velocity upward of 20 feet per second, and the initial height of 5 feet per second, we end up with this equation, -16 t squared plus 20t. I'm just going to highlight that 20 comes from the initial velocity upward, and plus 5 is the starting height. And we want to calculate the maximum height of this. Now we can do this using Vieta's formula to get the vertex. We can complete the square. If you're having trouble with this, you can also use Desmos to do this as well. Okay, but make sure you log in to the website so you can we can keep track of your progress. Okay, so here, if we want to find out the maximum height, what we can do is we can plug in, or so we can just complete the square. So I'm going to do that. I go -16 t squared minus, plus, so it's going to be minus, factor out the negative, so we're going to end up with 20 over 16 t plus blank plus 5. So I'm going to simplify this to 5 over 4. Okay, and so when we take half of that and square it, we end up with 25 over 64 times that both sides. So just go to that different color since that's added in. So taking half of that and squaring it, okay, we get 25 over 64. And we're going to multiply that by 16, so we get 25 over 4, and we're going to add 25 over 4 to balance off that equation, okay, because we have -16 groups of that. If I want to then solve for this, okay, I'm going to complete the square here, so it's going to be -5 over 8 squared. And then that represents the maximum height. That's going to end up being 45 over 4. Okay, so the max height in decimals is going to be 11.25 feet. Okay, that represents the maximum height. We could also find out like different things about this. We can find out the zeros, when does it hit the ground. Okay, we can, by making this equal to 0 and see where we can solve for. We could also find what is a height. Okay, maybe I'll ask this question here. So what is the height at t equals, let's say, 2 seconds. Okay, we can plug in 2 seconds here, so height at 2 is we're going to be -16 times 2 squared plus 2 20 times 2 plus 5. So we're going to end up with, this is going to end up going, it's going to hit the ground before that. So we're going to end up with negative height. So it looks like 16 times 4, negative 64, plus 45. So the height is going to go below the surface. Looks like it's going to be negative 19 feet below the surface. Okay, so we can calculate heights by plugging in time. We can find the maximum height by locating the vertex. We can do that in a few different ways. One way is completing the square. Another way is use the Étiez formula to find the x coordinate and then plug that in. If you're having difficulty with that, you can always just graph these, okay? But I want you to try to do these algebraically if you can. If you're finding that it's too hard to do it algebraically, go ahead and do it on the graph on Desmos.